In section 6.4, number 9, we were directed to solve this equation in 0 to 2 pi by squaring both sides is our hint. I'm looking at this though, and if I square it as it is, then I'm going to get a complicated expression on the left with tan and secant in the same term. So in order to avoid that complication, I'm going to move the secant over to the right by adding a secant x to both sides, which leaves me with tan x on the left and secant x minus 1 on the right, since these will cancel each other. So my next step is to take that hint of squaring both sides. So I'll square the left and I get tan squared x, and squaring the right, that's a perfect square trinomial, so I'm going to FOIL that. So when I take this thing squared, I get that, and this thing squared, I get secant squared x minus 2 secant x plus negative 1 squared is 1. So now I can look for my identities and I can replace this guy with a 1 plus tangent squared x. And I'll just rewrite all the rest, minus 2, not changing anything else at this time on this line. And then I want to get rid of those tangents, because I can see now that I can combine those like terms. So if I have a tangent on both sides, I will just go ahead and subtract that. That's not a division bar, that's just underline. So I'll subtract that from both sides, so I'm left with, on the left, a 0. And on the right, I have, these guys have canceled out. And I'll also notice that I can combine these like terms of 1 plus 1 and get 2. And then copy down that minus 2 secant of x. Now I'm going to bring over the secant x to the other side. So I'll add 2 secant x to both sides, and I get 2 secant x on the left and 2 on the right. Dividing both sides by 2, that gives me secant of x equals 1. So you can see I'm just kind of manipulating it algebraically until I can kind of whittle it down to one trig function, and then I can take the secant inverse of both sides. In fact, actually, before I do that, I'm going to change this to cosine because that's a little easier to find. So I'm going to change, I could do that, what I just did, but I think it is easier to do it this way. So cosine inverse, cosine of x is the inverse, the multiplicative inverse of secant. So inverting both of these, I still get a 1. And that is a little bit easier. I'll take my cosine inverse of both sides. So on the left, I just get x, and on the right, cosine inverse of 1 is x equals 0.